talk about demand. Even though it's good to want things, in economic terms, that's not enough to be able to say that you actually demand something. Formally speaking, demand is defined as being willing, ready, and able to purchase a particular item. So if you really want it but you can't afford it, you don't really demand it. If you want to buy it tomorrow, you still don't demand. Ready, willing, and able. The thing that we don't distinguish is how you're able to pay for something. We don't know whether you have cash up front, whether you're paying for it on your credit card, whatever it may be. We just say that you have the funds in some way to make this transaction happen. We can define demand as either individual demand, how much one person wants, is ready to purchase, and is able to purchase of an item. Or we can talk about market demand, the sum of the demand for all of the individuals in a given market. You'll notice that there's an important time element to the concept of demand. The number of ice cream cones, for example, that I demand would depend on whether I'm talking about ice cream cones in a given day, probably less than one, or in a given week, maybe one or two. In a given year, you would keep getting different numbers depending on what time units you put on demand. Now, economists are often sloppy and we don't explicitly put that into the axis of our graph, but it's important to remember that it is always there. This time element also makes it more logical to say things like, I'm demanding 2.5 ice cream cones. To say, for example, I'm demanding 2.5 ice cream cones per week would really just mean that I'm demanding 5 ice cream cones every 2 weeks. The general rule we have about demand, which is referred to as the law of demand, is that all else being equal, individuals demand more of a given item as it gets cheaper. So for example, I'm going to demand more ice cream if the ice cream costs $3 per cone than I would if the ice cream cost $5 per cone. The important thing to remember here is that when we're thinking about the price to a consumer, we're taking into account all of the different components of price the consumer has to pay, including things like taxes, surcharges, required maintenance costs, etc. In a behavioral sense, consumers might not treat all of these different aspects of price the same, but for the basic model, we're at least going to start with the assumption that the consumer internalizes all of those different components of price. When we talk about a demand curve, what we're really referring to is a graph of price versus quantity demanded. You'll notice here that I labeled both a lowercase q and an uppercase q. The distinction that we make in economics a lot of the time is that we use the lowercase q to refer to individual demands, and we use the uppercase q to refer to market demand. The same concepts are going to hold when we talk about individual supply versus market supply. So let's think about a demand curve represented by the equation quantity demanded is equal to 40 minus 5p. The first thing we want to do is say, well, how do we graph this on our axes here? You'll notice that the way that we wrote this demand curve is a little bit different from what you may have seen in your math classes, because we have the variable on the x-axis as a function of the variable on the y-axis. This is just a convention in economics, and it gets very frustrating sometimes, but it is what it is, and you can't really fight the trend at this point. So we're just going to think about, well, how can we go about plotting this even though it is in somewhat of a strange form? For a demand curve, the easiest thing to do is just think about what the different intercepts are. So you'll notice that the point on the p-axis here is the point where quantity is equal to 0. So we can go over to our equation and think about, well, if quantity is 0, what is the corresponding price? Well, if quantity is 0, then we just have 40 minus 5p equals 0. Or 5p equals 40, p equals 8. So when quantity is equal to 0, p is equal to 8. And we can put a point, maybe write something like this. Now let's think about the other side of this. The point over here on the q-axis of our demand curve is the point where price is equal to 0. So let's think about where that has to be. Well, if price is equal to 0, quantity demanded is just equal to 40 minus 0, or 40. Notice I'm not really drawing to scale, it's not usually very important. We can see from the form of our equation that this is just going to represent a line on our price and quantity axes. So we can just connect these 2 points. Notice here you get a downward sloping line, which isn't surprising given the law of demand that we talked about earlier. As the price of an item goes up, consumers are demanding less of it, or vice versa, as the price of an item goes down, consumers are demanding more. Notice here that we're holding everything else that could possibly impact demand. I'll come back and talk about this in a little while, things like income, tastes, expectations. We're holding all of those things constant and just thinking about how price affects quantity demanded. Let's think about what the slope of this demand curve is. We say that slope is represented by the change of whatever is on the y-axis divided by the change in whatever is on the x-axis. So in this case, we could say that the slope is equal to the change in P divided by the change in Q, or say 8 minus 0 divided by 0 minus 40, which is negative 1/5. You'll notice that when we have the law of demand being satisfied, we get a demand curve that has a negative slope, which corresponds to the demand curve sloping downwards like we see here. In theory, we could have a demand curve that would slope upwards, and we do have names for those type of things, but in practice those examples are very hard to find, so we can say that in the vast majority of cases, demand curves in fact do go in this direction. One other thing that's helpful to note is that when we talk about moving from one point to another point on the same demand curve, we refer to this as a change in quantity demanded. In other words, when we have a change in price that causes us to move from one point to another, we say that this is a change in quantity demanded. We'll see how this differs from a change in demand, which we're going to talk about in the next lecture. Let's say you're super stubborn and say, I need my demand curve to look like it does in my math classes because otherwise I really don't understand what's going on, it's all too confusing. One thing you can do is you can rewrite the demand curve as we see here, and we can just solve for price so that we in fact do have the variable on the y-axis in terms of the variable on the x-axis. In this case, we would just go through and put P on the left-hand side and say 5P is equal to 40 minus quantity demanded. We would then divide through by 5 to get that price is equal to 8 minus 1/5 times the quantity demanded. This is referred to as the inverse demand curve, and it really answers the question, for any given quantity, what is the price that we can charge such that we have that many customers lining up at the door? Whereas the regular demand curve says for any given price, how many units of that item are demanded. We're not really trying to imply a causal relationship in one way or the other, we're rather just trying to say that price and quantity are correlated in this way. Once you have the demand curve like you see it in your math class, it's pretty straightforward how it relates to the graph that we see here. We have our 8 as our y-intercept, and then we have our negative 1/5 as our slope that goes right here. That said, it's usually easier to become familiar with how to graph the demand curve directly rather than how to move it around and solve for P every time you have to graph a demand curve. Next time we're going to talk about the other determinants of demand, such as income, prices of related goods, tastes, and expectations, and then think about how we can change this demand curve based on changes in these non-price determinants of demand.